Okay, hello. So I want to explain the architecture of the blockchain and the flow of that. So first, it's the architecture. So we have the Bitcoin network topology. Suppose we have three nodes, like there are 50 and 51, and then 2 here. So we have three nodes like 5000, 5001, and 5002. Here we have the network. Oh, where's my cursor? We have a network in the distributed system. Then below that we have the chain. So each of this, we have the chain, and we have the chain here. Then below, we also have the transaction pool. So like TX pool, and here TX pool 2, and here TX pool 2. Okay. And for the last, we have the server, which is this REST API. So like this the REST, it is the REST 2 and it's the REST 2. Then how the node do some connections with the external applications. Here, they communicate in the distributed system with external app here and applies to all. So here also applies and here also applies. And the external applications can be in user's form or the API or application program interface. And then for the component, okay, I will select all first. How to delete it? I think I messed up. Hmm. Okay, I just save this and open a new pane. So there are some four class used in the code. The first is the transaction, or I will just use the X here, the X class, and then the block class, and we have the blockchain class too here, like the blockchain, and we have the node data structure. Okay, we have the node also. So how do it works? First is the transactions. The transaction contain like there is the sender and then the recipient or the receiver and the amount of the transactions. So we have like three parameters, the main three parameters here, and the function is to represent a transfer unit in Bitcoin and server relation for hashing and for equality check in this TX or the transaction class. And the second class is block class. There are so many data structures like the block structures, index, and then the timestamp, the data, here the lies the data, and the previous hash, like there are previous hash, the nonce, there are nonce, the Merkle roots, the hash. So the block contain many, and the function of the block class is as a container for multiple transactions is first, and implementing the proof of work mining and keeping its integrity with the hashing with cryptographic SHA-256 and linking to the previous block for the chain integrity. And the third class is the blockchain. Oh, where's my cursor? Okay, the blockchain. There are like a chain, which is the list of block or something like that. And then the difficulty for the proof of work for the mining, for the default is 4 to make it more easier. And the uh, transaction pool is to contain spending transactions and the mining reward. So after mining, the user will get the reward for mining. The functions, yeah, it's to manage the entire blockchain state and then to manage the mining process and calculate balances from the transaction history. For the last class is the node class or for to network communication layer. First, we have the port here, or the network port for communications, yeah, and the blockchain or the chain, yeah, the chain is for local blockchain copy, and peers, which is a peer as set to set of peer node addresses, and the app, which is Flask. So the web server for REST API. The functions of the node is to uh, HTTP server external communication and peer-to-peer networking with the peer nodes, and then to broadcast transactions and blocks also, and to configure solution and for synchronization. Okay, I think we can erase this all, or I just make it new. Then we have the API layer. So here is the API layer. Okay, the API layer. We have a post request, which in the transaction endpoint to submit new transactions. Okay, and then we have the get slash pull or the pull endpoint to view pending transactions, and we have get slash balance endpoint to to check the balance. So we know how balance, what is the balance of some address. And then we have the mining, which is the get slash mining. Yeah, it's to mine, to start mining process. And we have the blockchain query with get slash chain or the in the chain endpoint to retrieve entire blockchain. So like B chain to retrieve entire blockchain. And for the network, okay, I just separated. For the network, I have like post, nodes, and register. Yeah, register is to register peer nodes. And then I have get slash node slash resolve to trigger consensus. So here we can trigger the consensus, and we can do get slash peers here, get slash peers to list connected peers. Okay. Okay. And for the last, for the network, we have a post transaction. Yeah, just the transaction receive to receive broadcasted transactions. And the second one is to post block to receive broadcasted block. So it's just like broadcast handling in the blockchain system. So how do the flow works? First, we have the startup process. In the node creation, first we will do node creation, and what it will do, first it will init Flask or the web server, whatever like that, init the server, and create empty, sorry, I just want to make empty symbol, create empty blockchain with Genesis block, so like the initialization, and then initialize, oh, where is it? Init empty transaction pool and set up REST API, yeah, REST API, and then start listening to port. Okay, that was the node creation process flow. And the second flow is the Genesis Genesis block creation. So like we set the index or the IDX to 0, and then for the time stamp is the current time, and we make like we init the data, which is empty array, and then we have the previous hash here. So this is previous hash, which is uh, 0, and we can start to calculate the hash using SHA 256, and then we can add to blockchain. So there are the Genesis block creations process. And for the network setup, so after we make the Genesis block, we can start to set up our network or set up network manually. So each node registers peers via node slash register, or yeah, in the API implementation recently, and we can peer list stored in memory, so it not having like static storage, or not static, what is the language, like a disk, so like it safe in the memory like RAM, so only when the program is running. And we make the topology, okay, which will make explain later in the code. So, and the second one, we have the transaction lifecycle flow. So what is the transaction lifecycle? Transaction lifecycle. First, we have a user submit transactions, and then we do like post to slash transaction to add the transactions, and we validate required fields like the sender, recipient, and amount, so it won't it always valid, I mean. And we create transaction object, or if you're familiar with Solidity language, it when you broadcast something to some address like setup address, it will make a transaction object which deployed to where, like the address is deployed to where, and with it will instantiate transaction class. And after we create the transaction object, we do duplicate check to check like yeah check against whether a pool is exist or not. And after that we can add to local add to local transaction pool add to local transaction pool like add to nodes transaction pool, and we can start to broadcast like okay like broadcast to all peer nodes. And here in the broadcast we HTTP post to all peers, so we access the slash transaction slash receive endpoint. And the last is the peers will add to their pools. So each peer adds to their pool with the duplicate prevention we did in the previous step with in the circle. And for the third flow is the mining process flow. So how the mining works? Uh, First, yeah, the client will call the get slash mine to request mining. And then after that, the program will synchronize the transactions like pulls from peers. So it will fetch transactions from peers to ensure the complete pool. And after we synchronize, we check the pool size. We can check the pool size. Like it just to verify the transaction list and sorry, to verify transactions access. And we can start to add mining reward reward transactions here to create real transactions like to none to miner address and add 10 Bitcoin. And after that, we can create new block. So create block here, create new block. Yeah, with the constructor, of course. And then after we create the new block, we can calculate the Merkle root. So here we can calculate the Merkle root. Yeah, in this step, we can build Merkle tree from transactions and hash pairs until single root. And after that, we can do like proof of work mining loop. So loop here, proof of mining loop to find nonce where hash starts with required zeros. In this implementations, the default is 4. So like we we matching the first 4 string to match zeros, all zeros with 4 lines. After we do proof of work, we can add the block to the local chain. So we append to local blockchain. We append the block to the local chain. And after that, we clear the transaction pools because the mining is done. So we empty local transaction pools, and after that, where's my cursor? Okay. And after that, we can broadcast the block to all peers. So the peers know there are new blocks that will append via post slash block. So it will do like longest chain rule and synchronize with other peers. Okay, talking about synchronization, I will explain the fourth flow, that is the block synchronization flow. First, after the broadcasting the it will receive block from peers. Okay, receive the block from peers, and we can do like a post here, post slash block endpoint, and it will do like HTTP request from peer node, and we can do some validation here to make sure if the required fields exist. After we check that, we can reconstruct the block object. We can reconstruct the block object. In this case is to convert JSON back to objects like transactions to block data. And we do some kind of deep validation, deep validation to do multiple validation layers. And there are two branch here. If valid, just add it to chain. Okay. But if it's not valid, we trigger the conflict resolution. So we like requestful chains from peers for comparison, just like that. And we also have in the fifth we have consensus flow. So how the consensus mechanism flow uh, works. First, we implement the longest chain rule. Okay, the longest chain rule. In the app, it will first get slash nodes slash resolve. Okay, and then making some query all peers for their chain. So we query all peers for the chain. So like the getting chain from each peer. And then we do some compare chain lengths, like find longest valid chain. After that, we validate it. So if we can run full validation on each candidate chain, and after that, we can select longest valid chain. We can do that. We can select longest valid chain. After that, there are some kind of decision point here, like decision point. First, if our chain is the longest, then we can make it like authoritative. And if the peer has more longest chain than ours, we can replace it. We can replace it to our chain. So we replace our chain with the chain peer has. Then after that, we update local blockchain. Local blockchain. Okay. We replace blockchain with the winning chain. Then the last one is the balance calculation flow or the wallet in the blockchain. So yeah, just to get slash balance, yeah, slash balance slash the address, like the address value here. Different each user has different address, and we can init the balance counter. Wait, okay. like we init to 0, of course, and we can iterate through the entire chain. So for each block in blockchain, so we iterate that. Then we can process each transactions in the block. There are some mechanism. If the address is equal to sender and it so the balance will decrease by the amount. But if the address is the recipient, we add it. So yeah, if there are sender parameters, we reduce the balance. But if the address is recipient, we add the balance. But if it's mining reward, we can add the balance with the mining reward. Uh, the final is, yeah, we can just return final balance. Final balance here, round to decimal. Okay. After that, we can just go to the demonstrations of the program. Wait, let me close this first. Okay. Okay, I have the Bitcoin implementation here. So I have these functions called calculate Merkle root to calculate the Merkle root and the transaction to handle the TX or transaction block to handle the block that is tractor and the node to the network. Oh, I think I missed one. Okay, the blockchain, yeah. The blockchain is like the the block in the chain. Yeah, just like that. And to run the applications, we can simply run it, just run it with like run.py. It will initialize three nodes, which is running on port 5000, 5001, and 5002. So yeah, it will set up node and we can do some commands right here. One alternation, two mind block, three check chains, four check balance, five check transaction pools, six synchronize nodes, show manual commands and quit. But to make it more fast, I made some like test script to test the implementations here. Right here, there are 700 lines, 700 and half. So where is the first test cases? Okay, the first test cases is, wait, hmm, okay, the first test cases is to test the basic node functionality to verify that each node can start correctly and having like the initial state correctly. So we check whether it has the Genesis block and making the empty transaction pool and initialize balance check. And for the test case 2 is to register our peers. So we register each node with two peers, two other peers, and we verify each node whether is it have two peers registered. So that is the test case 2. And for the test case 3 is just like to test the its implementation to add or to share and to validate transactions. So first we can add single transaction here, Alice to Bob, and then for the two is to verify the transaction or the propagate to all nodes. And then we can add multiple transactions and verify transaction propagation and test duplicate prevention or invalid transaction data. For the fourth is to test the mining functionality. So like yeah, we get the initial state, we can mine the block transactions and verify block add to all chains, and we can also check the transaction pool status. Then we can test mining behavior with few or no transactions. And we can also verify the mining rewards. For the test case 5, we do some kind of verify the calculation accuracy from the balance in the blockchain history. So like we do analyze 3 blocks with the total of 8 user transactions and calculate balance and verify consistency each nodes. For the test case 6, we add transactions to different nodes and then we verify cross-node transaction propagation, and we can mine in the different node, and we can verify block propagation to all nodes. For the test case 7 is to test the consensus and the validation. So we can force consensus check to all nodes, and we can verify chain consistency after consensus, and we can check if the chain length is consistent. And for the test case 8 is to just error handling, like test server responsiveness, invalid transaction data, and not existent endpoint. Yeah, just like that. And what we can do later. Yeah, I think it's like the demonstrations. We can start to mining or start to access the program. Not mining, I mean like to run the blockchain program. So to run it, I use test because it covers all of the process. So we can run and wait until it's reached the end of file. Okay, this is the result. Like yeah, just take it like 1 minute with total assertion of 61. Past test case is 56, failed one, and we get warning 4. And the success rate is 98. So we analyze first the nodes successful start in this port and ready. For the test case 1 is just the basic node functionality like the is check, Genesis block access, and Genesis block index on node, pass, all pass, and it checks for anti-transaction pool and initial balance. Then the test case 2 is to register our peers, and I say that we have each 2 peers on one node, so this is pass 2. For the test case 3, we manage the transactions, like this is the propagate, and this is the add transactions, multiple transactions, and duplicate transactions prevented. But yeah, it failed because of like the architecture or the distributed system not too good to handle. Mining functionality. So the primary pre-mining state Here's some data on the pre-mining state. It will mine the block with transaction passed and the block added to node, valid proof of work, valid proof of work. So then the transaction pool executable on node and hack transaction mining succeed, mining reward receive. And then the balance calculations with 3 blocks each. The name Alice, -31, Bob, Charlie, Diana, nodes. And 6 network synchronization, all pass. And for the 7 in consensus validation, it's iterative, so we can get, so our chain is the longest one. And for error handling, yeah, it's like that. Okay, so I think that's all for the Bitcoin or the blockchain implementations. Hope you understand it and see you in the next time.